Hello everyone. In today's lesson, we are going to look at VLAN trunks. A VLAN trunk is an OSI layer 2 link between two switches that carries traffic for all VLANs unless the allowed VLAN list is restricted manually or dynamically. Basically, what this means is that this link here would link or would carry all of these different VLANs through this trunk to go to their destination. If you remember, previously we talked about the analogy of the trunk of the car. It can carry different boxes owned by different people, and those boxes are tagged. So a trunk is basically an implement to carry different VLANs through it to their destination. Now it says here that unless it is allowed, you can actually set restrictions on trunks. For example, if I set the restriction here that all of these three LANs are allowed, then it will carry the packet from these three LANs. But if I say the only allowable LANs are 10 and 20, LAN 30 packets would not go through the trunk. In a little bit, we will look at this. To enable trunk links, configure the ports on either end of the physical link with parallel sets of commands, meaning that this end here and this end here on those two different switches must have the same sets of commands. Okay, for example, if here you set the native VLAN as VLAN 99, here you must set the native VLAN as VLAN 99 as well. Sometimes trunk ports are also called tagged ports due to the addition of tagging. Trunks are layer 2 and carry traffics for all VLANs. And here is how you configure a trunk. You have to go into the global configuration mode with configure terminal and then set the interface that you want to be the trunk port. So interface, whatever interface it is, switch port mode trunk. Now in this case, when you do this command, switch port mode trunk, you set that port to a permanent trunking mode. It will not be an access mode anymore, it will be a trunk mode. And then you set the native VLAN to something other than VLAN 1. This is for security reasons. It is always a good practice to set your native VLAN to other numbers rather than VLAN 1. So switch port, trunk, native VLAN, and whatever the ID you want to put. 99, 55, 400. And then we are going to specify the list of VLANs to be allowed on the trunk link. So we type switch port, trunk, allowed, VLAN, and then the VLAN list. So if it's only one, let's say VLAN 10, we type VLAN 10. If it's more than one, let's say VLAN 10 and 20, we type VLAN 10, 20. So this is an example of the iOS command in practice. So we have switch port mode trunk. We are saying that the fast Ethernet interface is going to be a trunk interface. Switch port trunk native VLAN 99. We are saying that we are using the native VLAN 99. Switch port trunk allowed VLAN 10, 20, 30, and 99. So we are allowing all of these. Let's say, for example, we created a new VLAN, VLAN 40, and we did not change or update this. VLAN 40 cannot travel through this trunk. The native VLAN must be the same on both ends of the trunk for it to work properly. One thing about native VLAN in trunks is that it is not tagged. While all other VLANs are tagged, native VLANs are not tagged. To reset the default trunk settings, we use the no command. All VLANs are allowed to pass traffic, and the native VLAN will be reverted back to the default, which is VLAN 1. We can verify the default settings with the show interface fast Ethernet 01 switch port command. So here you have the no switch port trunk allowed, meaning that now we are allowing everything, and no switch port trunk native VLAN. That means we are reverting back to the default VLAN, which is VLAN 1. So if you see here, when we type this command, We can see that the access mode VLAN now is the default VLAN, the native VLAN now is the default VLAN, and the trunking VLANs are enabled for all. Reset the trunk to an access mode with the switch port mode access command. So right now, what it is trying to do is take an interface which was set to trunk previously and make it into an access port now. So here we have switch port mode access, and when you verify it, you would see that the mode is now access mode instead of a trunk. This is an example of verifying trunk configuration. If we have configured trunk for this interface, we can check it with the show interfaces command. It will show you that the mode now is trunk, the encapsulation used or the protocol used is .1q or 802.1q protocol, and then the native VLAN is 99. Now let's troubleshoot a little bit of VLANs and trunks. Common practice to associate VLAN with an IP network. Different IP networks must communicate through a router, which is logical. All devices within a VLAN must be part of the same IP network to communicate. In the figure, PC1 cannot communicate to the server because it has the wrong IP address configured. PC1 is in the faculty VLAN, which is VLAN 10, and the IP address given to PC1 is 172.172.10.21. The web server here is also in the VLAN 10, but the IP address is in the wrong subnet. So even though they are in the same VLAN, but they have different subnet address, so they cannot communicate with each other. If all the IP address mismatches have been solved, but the device still cannot connect, check if the VLAN exists in the switch. Sometimes we misconfigure and we forget to configure certain VLANs. It's always good to verify your work and make sure it is done correctly. If the VLAN to which the port belongs is deleted, the port becomes inactive and is unable to communicate with the rest of the network. This is something we discussed in a previous lesson. If you want to delete a VLAN, the first thing you need to make sure is to reassign the ports under that particular VLAN to another VLAN. And then, and only then, can you delete the VLAN. We cannot delete VLANs when we have ports assigned to it. So let's say there is no connection among devices in the same VLAN. They are in the same VLAN, but they cannot communicate with each other. So we check, is the port in correct VLAN? Firstly, we check that they are actually in the same VLAN. If it is yes, we continue. If it is no, assign the ports to the correct VLAN, and then we can continue. Now let's say they are in the right VLAN now, but they still cannot communicate with each other. So is the VLAN present in the VLAN database? How do we know that? We can use these commands, show VLAN, show interfaces switch port. Once you check that, if it is not in the database, create VLAN in the VLAN database. And if it is in the database, verify connection among devices in the same VLAN. We have to go and slowly check everything that has been done. Troubleshooting is slow work, but you have to do it step by step. Now, what happens if the trunk is the problem? Let's look at this. Let's try and troubleshoot trunks. Okay, native VLAN on local and peer ports match, meaning that on this side and the other side of the VLAN trunk, they have the same native VLAN. You can check that with show interfaces trunk. If it is the same, then it is okay. If it is not the same, then we have to change the native VLAN to match. In this example, you would see that while we were using VLAN 99, in the interface bus Ethernet 0/1 of switch 1, the native VLAN is set as 2. There will be a mismatch. So to solve this problem, configure the same native VLAN on both sides. So let's say we have done that and we still have a problem. We can check whether the trunk modes on the local and peer ports are compatible. This is something we will look at in a bit. And to check this, we can use show interface trunk. If you see here, the mode here is auto. There is dynamic auto, dynamic desirable, access, and trunk. Trunking issues are usually associated with incorrect configurations. The most common type of trunk configuration errors are native VLAN mismatches, trunk mode mismatches, and allowed VLANs on trunks, meaning that you have different native VLAN on both sides of the trunk. You have different modes or incompatible modes on each side of the trunk. Allowed VLANs on trunk is you forget to put certain VLANs that is allowed to traverse across the trunk. These are the usual problems that happens in configuration. When a trunk problem is suspected, it is recommended to troubleshoot in order shown above. Incorrect port mode. In this example, Pt4 cannot reach the web server. The trunk links on S1 and S3 are verified and reveal that the S3 port has been configured as an access port. The command show interfaces trunk will give us information about the trunk, whether or not it is set and other information regarding it. But let's move on and look at something more specific like show interface fast Ethernet 03 switch port. Why do we look at the specific one? Because this is how, or this is where the data will travel. So when we look at switch 1 fast Ethernet 03, the mode is trunk. Then we look at switch 3, the same show interface fast Ethernet 03 switch port command. We see that the mode here is access. So one is trunk and one is access. So we have an incompatible mode here. To resolve this issue, S3 F03 port is configured as a trunk link. Now both of these are trunk incorrect VLAN list. In this example, PC5 cannot reach the student email server. The output of the command switch port trunk allowed VLAN reveals that S1 is not allowing VLAN 20. So here we see that PC5 is in VLAN 20, but PC5 cannot reach the student email server. We go to S1 and we show interfaces trunk. So we want to see what interfaces are trunk and what are the VLANs allowed on it. We find that on the fast Ethernet 03 interface, which is this interface over here that connects to S3 and then to PC5, the only allowed VLANs are 10 and 99, meaning that this is VLAN 20, it is not allowed to travel here. And of course, PC5 cannot reach the email server. To resolve this issue, S1 should upgrade its F01 port and configure it to allow VLANs 10, 20, and 99. This is an overview of dynamic trunking protocol. Dynamic trunking protocol, or DTP, is a proprietary Cisco protocol. DTP characteristics are as follows. It is on by default on certain switches like the Catalyst 2960 and 2950. Dynamic auto is default on these two switches. It may be turned off with the non-negotiate command, like this, switch port, non-negotiate, and then it will turn it off. It may be turned back on by setting the interface to dynamic auto. Setting a switch to a static trunk or static access will avoid negotiation issues with the switch port mode trunk or switch port mode access command. So when you use these two commands, switch port mode trunk, switch port mode access, what you are doing is you are telling that particular port that you are a trunk port or you are an access port. So they will just follow that. Dynamic trunking protocol is, I'm not sure which one, but I'll negotiate. The switch port mode command has additional options. As previously mentioned, you can use the switch port non-negotiate configuration command to start the DTP negotiation. Now the options under switch port mode are access, dynamic auto, dynamic desirable, and trunk. Access is permanent access mode and negotiates to convert the neighboring link into an access link. So he says, I am access, I want you to be accessed. he tells his neighbor. Dynamic auto will become a trunk interface if the neighbor interface is set to trunk or desirable mode. Dynamic desirable actively seeks to become a trunk by negotiating with other auto or desirable interface. Trunk is a permanent trunking mode and negotiates to convert the neighboring link into a trunk link. So if you see here, when the mode is either access or trunk, they are steadfast in what they are, and they want their neighbor to be that as well. They will negotiate to convert their neighbor to be similar to them, either access or trunk. Now, when you talk about dynamic, now dynamic is negotiable. You can imagine dynamic here to be trying to please the neighbor. So both dynamic auto and dynamic desirable can be negotiated to fill in or to follow what the neighbors are. Let's say for interface fast Ethernet 01 here, we do a switch port mode and then a question mark. It will show you or list down all of the basic modes that it can have, either access, dynamic, or trunk. And if you choose dynamic, and then it will further give you options whether it's going to be dynamic auto or dynamic desirable. So let's look at this example. In this switch, we are looking into the fast Ethernet 01 switch port. So show interface fast Ethernet 01 switch port, it will show that the administrative mode is dynamic auto. No configuration is being done here, but by default, this interface is set to dynamic auto. So then you have to configure it whether to be access or trunk. DTP configuration options are as follows. Let's read this table as if this is one end of the link and this is the other end of the link. So if one neighbor is dynamic auto and the other neighbor at the end of the link is dynamic auto, then it will become access. If this neighbor is dynamic auto and the other end is dynamic desirable, it will become trunk. If he is dynamic auto and the other side is trunk, it will become trunk. If it is dynamic auto and the other side is access, it will become access. So basically, only when the two sides are dynamic, it would change whether it is a trunk or an access. If it is trunk, it will always be a trunk. If it is access, it will always be access. Now, if you see here, one neighbor is trunk and the other end is access, and he says limited connectivity. And this is true. Why? Because trunk needs tagging and access ports do not do tagging. So then we would have a problem. While it seems like a good idea to have this dynamic option, it is actually not. The best practice is to know your network and set it whether it is trunk or it is access. It does take a little time to read, understand, and digest this. But if you do the labs and the exercises, hopefully you will understand better. So until the next lesson, goodbye everyone.